Hello everybody, in this video we will reactions again, another SN2 reactions of alcohol with PCl3 and PBr3, and we'll go over the mechanism. So quick recap, SN2, what's SN2 stands for? Substitutions, nucleophilic, 2 stands for bimolecular reactions. What else we know about SN2 reactions? Well, SN2 reactions invert the stereochemistry, right? So that's one key point that I want to keep highlighting is invert the stereochemistry if there is a stereocenter, okay? And what kind of reactions go through SN2? What kind of alcohol reactions go through SN2 reactions? Just like we had with SOCl2, PCl3 and PBr3, they do really well with primary. Primary alcohol is the best type of alcohol that you can react with. Secondary does decent. So primary is the best. Secondary is okay. Secondary alcohol. But tertiary alcohol, this method won't work. Okay, so keep that in mind. Tertiary alcohol is a no-go. All right, I think we are cutting out the screen from the bottom, from the side. So tertiary alcohol is a no-go. Okay, so let's try to do the reactions. So you have an alcohol, and it doesn't matter what you're using, PCl3. If you use PCl3, that's basically OH would be replaced by chlorine. And if you use PBr3, the OH would be replaced by bromine. And if there is a stereochemistry involved, so make sure you invert the stereochemistry. So let's draw a quick mechanism for this thing. Let's say we have OH. Oxygen has lone pair. So what this will do is it will create, so the lone pair on oxygen will have a nucleophilic attack on phosphorus, and that will push out one of the chlorine away. So then you will have OH plus and then PCl2. Okay, so now you got OPCl2. So what this means is this is now a better leaving group. So this whole thing is a better leaving group. So now you can actually break the bond here by neutralizing the positive charge on oxygens, right? However, if I break it, you're basically creating a primary carbocation right here. So that's not going to happen. However, remember we just created a Cl minus in the last step. So Cl minus we just created here by removing it. So that Cl minus would act as a nucleophile and attack. So both of these things are happening together. So the attack of the nucleophile and removal of the group, removal of the leaving group happens together. That's why it's called SN2 reactions. Happens together. So obviously we got one molecule here, one unit. This is your units. And the other unit is at the bottom. So chlorine, one unit is attacking here. So what would be the next step? Well, the next step is kind of easy. So you got chlorine is connected, right? And the leaving group was OPHPCl2. All right, so that's kind of the pretty much the end product. We care about the product here. We don't worry about the side products, but just know it's there. All right, so now let's look at how we can exploit this one. So quick recap. This is SN2 attack, right? So which direction it will attack? So this is an SN2 attack. And SN2 attack always happens from which side? from opposite side. From opposite side of the leaving group. So keep that in mind when you're solving problems. So let's look at a couple of problems here. So let's say we got something like this. Let's say we have dash 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 OH and PCl3. Okay, so in this case, the leaving group is pointing to the down. So the leaving group, this is our leaving group. It's to the down. So which means our incoming group, Cl minus, which direction it should approach? It should approach from the top. Okay, so the top. So now we're gonna have our product where the chlorine is approaching from the top and the leaving group has gone away. So that's your answers, right? So where chlorine is pointing to the top. Okay, so if you notice, there is like for visualizations, there is a hydrogens that we don't see right there. There is a hydrogens from there. That hydrogen will be pushed downwards. So both of them switched in the next step. So you don't need to show the hydrogens. Okay, so let's do one more problem. So let's say we got like this. Let's say this one has this, and then this one has OH. And then let's say the PCl3 and PBr3, they are both the same. Okay, so I will draw the mechanism for this part just for the sake of it to make you understand a little better. So what would be the answers? Okay, so let's draw the mechanism. So here it attacks, bromine goes out. So nothing changes with this methyl group right here. It was pointing down before. It is still pointing down. However, next step will be changed. So our oxygen is still pointing down because it is still there. But now we got OPBr2. This is where the fun happens. So Br minus will do a SN2 attack from top, right? Because why top? Because the oxygen is pointing down, so it has to approach from the opposite side, which is from opposite of the oxygens. Okay, OPBr2. Okay, there is a positive charge. I forgot to mention here. Okay, so there is a positive charge. So now the leaving group will go away and attack will happen from the same side, sorry, opposite side. And what you'll end up making is, so nothing changes there, but our incoming group, bromine, is gonna be here. So that's the beauty of this reactions. All right, let's stop the video here and we'll discuss more on elimination reactions in the next video.